Hello, this is Mrs. Ward, and I'm going to go over the review worksheet for Chapter 9 for sequences and series. So the first two, it says determine if the sequence is arithmetic. If it is, find the common difference, the 52nd term, and the explicit formula. So to do that, remember you take 15 minus 23 and you get -8. 7 minus 15, -8. -1 minus 7, -8. So they have the common difference. So my common difference, which I'm going to notate with a lowercase d, is -8. So I should say yes, it is arithmetic. And then it wants me to find the 52nd term, but before I can do that, I'm going to find the explicit formula. So I'm going to say a sub n is equal to my first term, which is 23, plus n minus 1 times my common difference, which is -8. I'm going to go ahead and distribute that -8. So I'm going to have minus 8 n plus 8. So I'm going to say a sub n is equal to 31 minus 8n, or -8n plus 31, however you want to write it. So then the next thing I want to do is find the 52nd term. So to find the 52nd term, I'm going to put 52 in for n. So 8 times 52. And when I do that, I end up with my 52nd term being -385. Okay, the next one, it doesn't give me a list of numbers, so to determine whether it's arithmetic or not, I probably should find the first couple terms. So I'm going to substitute in 1, so 6 minus 9 times 1, get -3. The second term will be 6 minus 2, 9 times 2, which is -12. The third will be 6 minus 9 times 3, which is -21. The fourth will be 6 times 9 times 4, which is -30. The difference between, if I take 12 minus 3, I'll get -9. 21 minus 12, -9. And that's this. That's going to be my common difference. So my common difference is -9, and I'm going to say yes, it's arithmetic. To find the explicit formula, they gave me the explicit formula, so there it is. Don't have to do any work for that. And then to find the 52nd term, I'm going to substitute 52 in for that n, and I'm going to have -6 minus 9 times 52. And when I do that, my 52nd term ends up being -462. The next one that gives you the sigma notation, and it wants you to evaluate each arithmetic series. So I am trying to find the sum. I am going to use that formula that says to find the sum of the nth number. You're going to take n over 2, and you're going to multiply it by the first term plus the last term. So that's the formula that I should know. So to find the 13th term, I'm going to first find the first term. So putting in 1, I'm going to have 5 times 1 minus 10, which will be -5. And then I need the 13th term. And the reason why I need the 13th term is because that's the last term. I'm going to do 5 times 13 minus 10. And when I do that, I end up with 55. So to find the sum of the 13th term, I'm going to take 13 over 2. I'm going to add that -5 plus 55. And when I do that, I end up with 325. The next one, I'm finding the sum from 1 to 9. So I am going to find my first term. So I put 1 in. So that's 4 times 1, and I get 4. To find the 9th term, I put in 9. 4 times 9, and get 36. Remember, I can only find the sum of finite series. When it's arithmetic, I cannot find infinite for summation for arithmetic. So the sum of 9 is going to be 9 over 2, 4 plus 36. And when I find that and do that on my calculator, however I want to do it, I get 180. Determine the number of terms in n's arithmetic sequence. So this is asking you to do the same thing that you just did, except for you're solving for n. You don't know what your top number is. So your formula is still the same. It's S of n is equal to n over 2 plus the first term plus the nth term. But you're going to have variables in here. They're telling you that the sum is this 1400. So I'm going to put that in there. I don't know what n is. I do know my first term because if I were to put in 1, I would be 2 times 1 plus 4. So my first term is 6. So I'm going to substitute that in. If I want to find the nth term, it's going to be 2 times n plus 4. So I'm going to go ahead and put that in there. Plus 2 times n plus 4 because that's my nth term. And then I'm just going to solve this. And this isn't big, solving it. I think getting this far was the hardest part. So I'm going to have 1400 is equal to n over 2. And then when I combine my like terms in here, this will be 10 plus 2n. And then what I did is I realized that the 2 would simplify. So this 2, this would be 5, this would be 1. So I'm going to have 1400 is equal to n times 5 plus n. So then, oh, it's going to be quadratic. 1400 is equal to 5n plus n squared. Set it equal to 0. N squared plus 5n. I switched things around while I was at it. 1400. This ends up factoring as n plus 40 and minus 35. So my choices for n are negative 40 and 35. Well, remember, when we're talking about these, my n is a number of terms, and it always has to be positive. So that eliminates the 40. So that means that I am finding the sum of the 35th term. I really like that problem. The next one is, it says, given the explosive formula for a geometric, so now we're switching to geometric, find the first 5 terms and then find the 8th term. So to find the first 5 terms, I'm just going to substitute 1 in. So this will be to the 0 power, so that'll be negative 3. To find the second term, this will be negative 3 times 3 to the first, which will be negative 9. The third term will be negative 3 times 3 squared, which will be negative 27. Fourth term will be negative 3 times 3 to the third, because it's always one less than the number term you're on, and that's going to be negative 81. And the last one, the fifth term, will be negative 3 times 3 to the fourth, which will be negative 243. Now it wants me to find the 8th term, so since it's given to me in an explicit formula, all I have to do is substitute that 8 in, so negative 3 times 3 to the 8 minus 1, if I want to be clear. And so that would be negative 3 times 3 to the 7th. And when I do that, I get negative 6,561. Okay, the next one, still doing the same thing. I'm going to find the first 5 terms and then find the 8th term. So the first term, I'm substituting in 1. So this would be negative 2.5 times 2 to the 0, which will be negative 2.5. The second term will be negative 2.5 times 2 to the first power. That looks like a 1, but that's a 0. And that'll be negative 5. Then I'm going to take the third term, so negative 2.5 times 2 squared. And that'll equal negative 10. Fourth term, negative 2.5 times 2 to the third, which will equal negative 20. And then finally the fifth term, negative 2.5 times 2 to the fourth, which will be negative 40. To find the 8th term, I'm going to have negative 2.5 times 2 to the 8 minus 1. Well, that's a 1. So I'm going to have A is going to equal negative 2.5 times 2 to the 7th, which will end up equaling negative 320. And here, it should make sense to go from here to here. I multiply by 2, multiply by 2, multiply by 2, and that's the number that I'm raising to the power. Just want to clarify that. All right, the next one, evaluate each geometric series described. So here, in poor planning on my part, they both end in 9, sorry. So my upper limit is 9. So this makes this a finite. So finite has a formula. And that formula is, oh, I'll write it over here. S sub n is equal to 1 I skipped 2. Why did I skip 2? Oh, I'll go back and get those two, but I'm here. So here I'm on 10. Sorry, I skipped two. So to find this, I'm going to take 1 minus r to the nth over 1 minus r. That's the formula to find the sum. So when I do find the sum of the ninth term, I'm going to take 1 minus my r, in this case is whatever I'm raising to the power, which is 1/3. I'm going to raise that to the ninth power all over 1 minus 1/3. If you use my favorite key, and my favorite key is not the summation key, my favorite key is the fraction key. You can put a fraction within a fraction so you won't mess this up when you put in your calculator. And your sum will end up being 9,841 over 6,561. To find this one, same formula. I'm going to do S of n is equal to 1 minus, this time it's -4 because that's what I'm raising to the power. I'm going to raise that to the ninth, all over 1 minus -4. And when I do that, I end up with 52,429. So now I'm going to pause so I can go get those other two problems that I forgot. So hold on a second. Okay, so here's 8 and 9 that I just forgot. It says, given two geometric sequences, find the recursive formula. So to find the recursive formula, I am going to first have to find out what my rate is because I don't know what my rate is. So I said a to the sixth, and I'm saying the sixth term because I'm given the sixth term, is going to equal the first term times my common ratio to the n minus 1, or fifth power. That's the formula. So in order to do this, I'm going to put in that -64 over 3,125, and that's going to equal my first term, which is -2 times r to the fifth. I'm going to divide both sides by -2, and when I divide both sides by -2, I end up with 32 over 3,125 is equal to r to the fifth. Then I'm going to take the fifth root of both, so fifth root, and do yourself a favor, take the fifth root of the numerator, fifth root of the denominator, so your calculator doesn't throw it into a decimal for you, but I don't know if it will or not. But I did it that way. So when I do that, I end up with my rate as being 2/5. So that's my common ratio. And so it wants me to write the recursive formula. Recursive formula comes in two parts. You have to have both parts. The first part is listing off what the first term is. And I'm fortunate because I was given the first term. My first term is -2. Then the next one, I'm going to say a sub n is equal to the previous term, or sorry, it's going to equal -2 times the rate to the n minus 1. That's one way that I can write that, is having n and then n minus 1 over here. Also correct is my first term is -2, and then I could have a to the n plus 1 here is equal to -2 times r to the n. Either one of those is acceptable, but you must have both parts. Oh, I back it up. Hold on. I forgot to put in my ratio, so let me put that in. I hope you were yelling at me. So this is 2/5. You have to put that in there, and this is 2/5. Raise the n minus 1. Yeah, so you have to have those parts. So you have to say what your first term is so you know what you're multiplying by. So if you don't give you the first term, you're not giving the whole recursive formula. Okay, number 9 is a little bit trickier than number 8 because I'm not given the first term. I can still find this though. So this one I'm going to look at, I have a to the sixth is going to equal a to the third times my ratio. But to go from 3 to 6, I had to go to 4, 5, and 6. So I had to hop 3 times. So I'm going to have to multiply that by the third. So I'm going to say 5/6 is equal to -180 times r to the third. I'm going to divide both sides by -180, and when I do that, I end up with -1 over 216 is equal to r to the third. Taking the cubed root, cubed root, and cubed root, cubed root, and I'm going to end up with -1 over 6, and that's going to be my rate. So in order to do the recursive formula, I need my first term. I wasn't given my first term, so I have to go back and find my first term. I can use either one of these numbers, but I always use a smaller number. So I'm going to say to get to the third term, I'm going to take my first term times my rate, which is negative 1/6. It's a 1 there. And I'm going to raise it to the second power. So my third term is negative 180. It's going to equal to that first term times negative 1/6 squared. So negative 180 is equal to 1, this will be a positive 1 over 36 times a to the first. When I square that 1/6, multiply both sides by 36, and I end up with a negative 6,480 for my first term. So my recursive formula is that my first term is at negative 6,480. Then my recursive formula is a sub n is equal to negative 6,480 times this negative 1/6. Oh no. Is to get to the next term, I'm going to take negative 1/6 and multiply it by the previous term. Forgot what I was doing there for a second. And you need both parts. That's one way, or you can switch this. A sub 1, negative 6,480. You can have this as n plus 1, and then this would be negative 1/6 times a sub n. They just mean the same thing, just switching the n a little bit. Okay, so that is 8 and 9. We've done 10 and 11. So now we're on 12 and 13. It says evaluate each infinite geometric sequence. So that's a different formula than the one that we just did because I'm looking at an infinite. And that formula, remember, is the first term, the sum to infinity. And you can only do this for a geometric sequence that has a ratio less than 1. Well, the absolute value is less than 1. And this is going to be a sub 1 over 1 minus r. So it's a much easier formula, I think. So when I go to find the sum to infinity of this, my first term, when I put in 1 here, this will be raising it to the 0 power, so this will just be 1. So it's 135 over 1 minus 1/3, because my ratio is 1/3, because that's what I'm raising to a power. And when I do this, I end up with 405 over 2, or you can give the decimal of 202.5. Okay, doing number 13, the sum to infinity. I am going to do my first term, putting in 1 here. This will be 1, so this will be 27 over 1 minus 1/3. And when I do that, I end up with 81 over 2, and as a decimal, that's 40.5. Either one of those answers is acceptable. And then just a quick reminder, your calculator will do these summations. We know that. Your calculator will not do these summations. That's a CAS thing. You don't have CAS. The next one, use mathematical induction to prove each statement is true for positive integers. Remember, these come in 3 steps. The first step is you have to prove that it works for S sub 1. Prove S1 is true. So if I look at this, the sum of the first term is 10. If I put in 1 to this formula here, I'm going to have 1 times 2 times 1 plus 8. So I'm going to have 1 times 10, which is 10. So it is true for the first. The second part of this mathematical induction is to assume that my sum of the k term is equal to, putting in k here, k times 2 times k plus 8. I'm assuming that is true. The last thing I'm going to do is I am going to prove that the sum of the next term is equal to the sum of the k term plus the next term. Ooh, that's a k. So to do that, I am going to put k plus 1 in here. So k plus 1, 2 times k plus 1 plus 8 is equal to, then this is k, 2k plus 8. And then to find the next term, I'm going to put in k plus 1 here. So that will be 4 times k plus 1 plus 6. I am going to try and simplify. This will be k plus 1. This is 2k plus 2, so 2k plus 10. And over here, I'm going to have, I'm assuming you guys just multiplied, so 2k squared plus 8k plus 4k plus 4 plus 6. I didn't combine any like terms, I just did it. I'm going to factor out the 2 if you don't mind. I wonder if you do mind. This will be k plus 1, and then this will be k plus 5. Everyone good with that? No, I can't hear you if you're not. So, okay, combining my like terms, this will be 2k squared plus 12k plus 10. I can see here that I can factor out a 2, so I'm going to do that. That'll be k squared plus 6k plus 5. That makes it easier for me to factor as k plus, oh, I should probably do it in the same order that I have it on the other side. K plus, whoa, k plus 1 times k plus 5. And that's equal to this 2 times k plus 1, k plus 5. And so it is true. You've shown that the left side equals the right side. Remember to do those. I don't think I've ever said it, but we've never done it. You can't add, subtract, multiply, divide anything to both sides. You have to work with the left side independently and the right side independently. So that's the proof, and that is good. Find each term described. So I want to find the third term in the expansion. So I'm raising this to the 4th power. So to find the third term, I know that that negative x is going to be raised to the 2nd power because it's always one less than the one I'm trying to find. So if that's going to be raised to the 2nd power, that means this y to the 4th has to be raised to the, oh, the y to, yeah, the y to the 4th has to be raised to the 2nd power because the 2 plus the 2 has to equal the 4. To find the coefficient, which I didn't leave myself room to write, let's move all this stuff over here. To find the coefficient, I am going to do that combination, permutation, and what I'm going to do is I'm going to do combination, and I am doing 4, choose 2, because of that 2 there. If you don't want to do that, you can do the Pythagorean, or Pascal's triangle Pythagorean theorem. 4, 6, 4, 1, and I want the third term 1, 2, 3. So when I do this, it should be 6. And let's see if it is 4 factorial over 2 factorial, 2 factorial. So this is 4 times 3 times 2 factorial over 2 times 1 times 2 factorial. Those will simplify, and I do get 6. So my coefficient is 6. Y to the 4th squared will be y to the 8th. This negative x squared will just be a positive x squared. And so my third term is 6y to the 8th x squared. So to do the next one, I'm also raising it to the 4th power, which means this 4 is always 1 less than the number of term that I'm looking for. So this will be raised to the 2nd power. The first term, this x to the 4th, whatever, I have to add to 2 to get to 4. So that'll be raised to the 2nd power. The combination here, this 4 goes here. Then this exponent here goes here. So we just did this one. This will be 6 x to the 8th times 16. So I'm going to have to multiply 6 times 16 and get 96x to the 8th. And that is my third term. Again, if you're not good at figuring out which term, you could do the whole thing, I guess, if you have time. So now number 17 wants me to expand completely. So again, I'm gonna do the boxes. So my coefficients are going to be, we just did them. My coefficients are going to be 1, 4, 6, 4, and 1. I'll chop that off. And then the first thing I have is this m, and then I have this 2. Those are my 2 terms of my binomial. So when I go to do this, I am going to first start with m to the 4th power. So this will go m to the 4th, m to the 3rd. I keep on going down 1 until I finally get m to the 0, which is just 1. The 2 goes in the opposite direction. You start with 2 to the 0, then 2 to the 1st, which is 2, 2 squared, which is 4, 2 to the 3rd, which is 8, 2 to the 4th, which is 16. Then to find this, I am going to multiply the 1 times the n to the 4th times the 2 to the 0, which is 1. I didn't write that, but that's 1. I'll write that. 4 This is what I'm going to multiply. I'm just going to highlight them all. And so when I multiply them all, I get, and this is 1, so then I get m to the 4th. 4 times 2 is 8, so plus 8m to the 3rd. 6 times 4 is 24, 24m squared. 8 times 4, 32m. And then 1 times 1 times 16, 16. And that is my whole expansion. Okay, doing number 18. I'm raising it to the 5th power. So if I do Pascal's triangle, so this is 1, 5, 10, 10, 5, 1. So my coefficients, I'll just write a C. The coefficients are going to be 1, 5, 10, 10, 5. Just a quick check. I have 1, 2, 3, 4, 5, 6 columns, which makes sense because I'm raising it to the 5th power. I should have one more term than the power that I'm raising it to. This first term is 3x, and then the second term is y squared. So I'm going to start with 3x to the 4th. So 3x to the 4th, which will be 81x to the 4th. Oh no, to the 5th, my bad. To the 5th. Here, this is 81x to the 4th. I'll put that in there. This is to the 5th, which makes this, oh, eraser, eraser, eraser. 243. Fifth, 243x to the 5th. So this is 3x to the 3rd, which is 27x to the 3rd. This is 3x squared, which is 9x squared. This is 3x to the 1st, which is 3x. And this is 3x to the 0, which is 1. The y squared starts off being raised to the 0 power, so that'll just be 1. Y squared raised to the 1st power will be y squared. Y squared squared will equal y to the 4th. Quick check, this 2 plus this 3 is equal to the 5. Y squared to the 3rd is equal to y to the 6th. Y squared to the 4th is equal to y to the 8th. And finally, y squared to the 5th is equal to y to the 10th. Multiplying my boxes, and I'm going to write it down here because that one other one's in the way. I'm going to end up with 243x to the 5th plus multiplying the 5 times the 81, that'll be 405 x to the 4th y squared. Multiplying the 10 times the 27, that'll be plus 270 x to the 3rd y to the 4th, plus looping around. 10 times 3 will be 30, so this will be 30 x squared y to the 6th. 5 times 3 will be 15, so this will be 15x y to the 8th, and then y to the 10th. And that is my full answer. And that completes the review worksheet. Remember, you can have a note card. 4x6 is the largest I'm going to take. That has all the formulas from this section, so you might want to write down the explicit formulas for both geometric and arithmetic. You definitely want to write down the summation formulas. And I think that's about all you'd really need. All right, I hope this helps, and we'll see you next time in class.